This worksheet's on the angle side angle postulate using AAS and hypotenuse leg. And so if we look at number 1, they're right triangles, and we see that the two hypotenuses are congruent, and that reflexive side between them gives us a leg. So by HL, those triangles are congruent. Looking at number 2, we have side angle side pattern. So, and also it's important to see that the pattern is the same on both triangles for it to match, and so they're congruent by side angle side. Here we have two right triangles. We've got a side, but there's not enough information about what's going on with the others. But we do have parallel, well, could we do vertical angles? I'm also thinking we do parallel lines with transversals for angles if we needed to. Number 4, we've got angle, angle, side. So angle, angle, side pattern. If we look at number 5, we've got that side shared between the two. That gives us a side, but the two angles is not really enough information to do anything with that. Looking at number 6, it's a right triangle, and we can see that the two hypotenuses match and the two sides match, but it's not really hypotenuse leg. Oh yeah, I guess we could say it's hypotenuse leg. And completing the proof for number 7, we want to prove that the two triangles are congruent. Looking at them, we've got a side, we've got the angle by vertical angles in the center, and we've got an angle. So angle, angle, side's the pattern we need to go for. So we need to bring that out in our steps. So angle E congruent to or equal to angle T tells us that angle E is congruent to angle T, and that gives us an angle. And then SO segment is congruent to SO segment, or equal to SO distance is equal to RO, which means that SO is congruent to RO as segments. That gives us the side that we need. And then by vertical angles, angle EOR is congruent to angle TOS. Their measures are equal, which means that the angles are congruent. So that's vertical angles are congruent. And we have an angle, angle, side pattern to show the two triangles are congruent to each other, or to prove that they're congruent to each other. Looking at number 8, we've got basically it's an isosceles right triangle. The two 6s are congruent, and the other one is congruent. We got a 45-degree angle, and with that 45-degree angle being with number 4, the other angle at A also has to be 45 degrees, and the angle at the top of the right triangle needs to be 45 degrees. And we really have right angles there on the longer side at the top of the triangle where the two 6s are at, because we have two adjacent angles that need to add up to 180 that are congruent to each other, so they must both be 90 degrees. So that gives us a side angle side pattern to show that the two triangles are congruent, and angle A is going to be 45 degrees and B is going to be 90 degrees. Looking at number 9, we have parallel lines. We can do alternate interior angles with the horizontal ones. We can do alternate interior angles with the vertical ones, and jump the 45s and the 25s around to their congruent angles. And since all together the triangle sum says they have to equal 180 degrees, we can find out that angle B must be 110 degrees. So we've got 45 degrees for A and 110 for B.